Welcome to In the Clinic by Dr. Butch Levy. This month's episode is titled An Introduction to GI Disease.
Good morning. This is Dr. Butch Levy, and we are going to embark on a series of discussions over the next couple months that will take a pretty deep dive into GI disease. It's becoming much more understandable how the digestive system works, the causes of problems with it, and the treatments. Now, there are all different levels of treatment, and we're going to try to look at how the different paradigms interact with people with GI disease and give you more tools to be able to choose what you need and know when perhaps referral for more serious disease to a Western physician might be appropriate. So the impact of GI disease certainly cannot be underestimated. When GI issues and problems come up, they intermingle with affecting a number of other systems that have to be considered, which often is the case and often ignored. So you can't just treat basic symptoms of a GI problem and expect a global response in terms of how people do. It's important to recognize, obviously, that absorption and nutrition are an essential part, but there's a huge immune system involved with the digestive system. It impacts detoxification. It impacts sleep. Most people don't recognize that when their digestion is off, their sleep is impaired. So there are a lot of areas that have to be looked at, and as some of these digestive issues improve, you'll see other areas get better, but you have to be aware of them in order to be able to know when to offer treatment along with what you're doing for the initial problem that the patient saw. I think that multiple paradigms become essential, and hopefully that's what we're here to discuss today. So we will do that. So when we're looking at, in this situation, I'm going to direct this much more at the intestinal system, large and small intestine at this point. We'll cover the stomach, the liver, the gallbladder, and we're also going to cover some of the malignancies that occur in these systems. So hopefully it'll be a complete view of what you need to do. I think that when we're talking about the small and large intestine, the normal function, as does the stomach, as does all of the organs, but in this instance, it's a protective barrier against invasion. It's the fort that acts to prevent unwanted antigens, bacteria, and toxins from entering into your system. We have an innate immune system that's our basic system, that are the front lines, the foot soldiers, that really recognize the initial onset, just like the metaphor seems to include. Oftentimes these are, while not genetically determined, they're there basically when we start at birth. And they don't have to be essentially prompted too much to be able to work. They're always in the process with the immune system of looking at possible antigens, as we see here with pathogens and foods and toxins and all the things that we generally ingest, and they act in a way to help protect us. Most of the time, it's with our white blood cells, with complement. There are certainly molecules that they can release in this innate system to attract more help. They certainly can create inflammation with cytokines. But this is the first standard. And hopefully in this setting, it is able to prevent any further problem from going on. And I think that's what it's really looking to do. And it's really looking at patterns. It's looking at, is this belong here or does it not? So these cells are macrophages, are white blood cells. And we have these dendritic cells, kind of cells with tentacles that are sampling what's going on. And what it's doing is it's recognizing different types of receptors, both on the surface and inside the cells, that give it information. So what we're looking at is these kind of letters that tell us about pattern-associated molecular patterns and damage-associated molecular patterns. And the cells are seeing those as foreign, but they're sampling through different receptors on the different cells to know what's going on. So they sense that there's a pathogen, they sense that there's damage, they are able to connect with that cell and get the information that says to it, it's not appropriate to be here. So you see the responses, you get the white blood cells engulfing them, offering poisons that will damage and kill the cell. It creates an inflammatory response through cytokines and chemokines, as we talked about. But this is the first battle. This is the initial meeting that goes on, and often it's very successful in managing what's happening. So when there is response here, and we know that while there's a lot of white blood cells and other factors, there certainly can be immune globulins that come into play here, which are IgA generally in the gut. And we have these Paneth cells, which produce antimicrobial peptides. So you sampled the environment, you've determined it's something that you don't want, you've created this response immediately that you want chemicals, you want immune globulins, you want natural antimicrobials to come and take care of this. And then hopefully this settles down and you don't have to continue having more response. And this is part of the problem we run into, is that if you keep bringing these certain antigen patterns and you continually ask the immune system to keep reacting to it, you start overstimulating it, or you can burn it out. So you want it to be working and stopping. That's what the goal is at this point. So we also have adaptive immunity, which I think that is a very important secondary response, or in some cases can be primary, but they too use these dendritic cells, these tentacle cells, and they can be in the lining cells along with the workings of the innate immune system. They're often a little deeper in the system, and they sample what's going on and send more information back to our lymph nodes. And the lymph nodes are often below the surface of the gut in the deeper layers in the Peyer's patches. And oftentimes these result in activation of our T cells. And T cells are there to help us fight infection. We have these CD8 cells that can be cytotoxic. We have helper cells that stimulate the production of more immune products and more T cells. But the big thing about adaptive immunity is that there is a memory that's involved with these cells, so that we keep a catalog of what's happened. And if you have another infection or you have more continuing insult, the immune system doesn't have to take time to gear up. It takes a while. That's the point. The innate system responds immediately, and it then calls in the reserves. It asks for the planes and the tanks and the missiles, but that takes a while for everything to gear up. And so the adaptive takes time. When you've set up the system so that it recognizes the situation is happening again, the memory can help speed the response so it works more quickly and more decisively.
We hope you found this training helpful. To continue watching this training and others, please visit eastwestmedicaleducation.com and click on the tab In the Clinic to subscribe.